Like the set interface, which has linked HashSet and TreeSet implementations, the map interface has the linked HashMap and TreeMap classes. The linked HashMap is a key value entry collection whose keys are ordered by insertion order. The TreeMap is sorted by its keys, so a key needs to implement, comparable, or be initialized with a specified comparator. Let's take a look at these in code. I've created a new project called Sorted Maps. I'm going to start by creating a student class. Before I work on this, I'm going to set up two records. The first is for course. This will be the courses a student will enrol in. I'll include these in the student.java file for simplicity. Course will have three fields, all strings, course ID, name and subject. The second record will be for a course purchase, so I'll call it purchase. I want this to have 5 fields. The first is the course ID, an identifier for the course they'll be purchasing, an integer for the student ID, and a double for the price of the course. In addition to that, I want a year and a day of year, both integers. The year will just be the year of the purchase, and day of year is an integer, which is between 1 and 365. These two pieces of information can give us a date. I'll add a method to this record called purchaseDate. It's public and will return a local date, which I've used once or twice before. I'll be covering dates in great detail in an upcoming section, so this is a preview of things to come. Local date has a static method named of yearDay that takes an integer for a year and an integer for the day of year and returns a local date instance. I'll be using this date a bit later as a key in my map. Let's get back to the student class and set up a few fields. First, I want a static int, last ID, and I'll assign that an initial value of 1. You've seen me do this quite often with student or employee classes because I want ID assigned as part of the construction of the object. The last ID used gets stored in this field. Students need a name. The ID field is going to get automatically assigned using the static last ID when a new student is created, and students will have a list of courses. I'll set up two constructors. The first will have name and course list as parameters. I'll add another statement to this constructor to set the ID. I'll increment last ID after the assignment with a postfix increment. I'm going to copy this constructor and paste a copy right below the first constructor. I'll change the second argument. The type will be my course record and its name will be course in lowercase. This is going to let me create a new student with just a name and single course. I'll remove all the code in this constructor and instead chain a call to the first constructor. I'll pass name and a new array list, which will include the one course passed to this constructor. Next, I'll create two getters, one for name and one for the student's ID. I'll include a method to add a course, so public void add course, and that has one parameter, a course. I'll simply call courseList.add, passing it the course argument. Lastly, I'll add a toString method. I'll replace that statement. First, I'll set up a string array called course names and make that the same size as the course list field. This is just going to store the course names. I'll use ArraySetAll to populate my string array using a lambda expression and using the index to retrieve the course and ultimately its name, which goes in my local array. From the lambda, I'll return a formatted string that has the student ID and the course names list. I'll use join on course names to retrieve a comma delimited list. Okay, so that's enough setup to let me simulate students registering for my courses. Getting back to the main class, I'm going to set up two different maps, both private and static. The first, I'm going to declare with a reference type of justMap. The key will be a string and the value is going to be a purchase record. I'll call this map purchases. I'll assign it a new instance of a linked hash map with no arguments for the constructor. For the second map, I'm going to make it the reference type navigable map with the key as string and the value will be student. I'll call this students and make it a new tree map. Using navigable map as the reference type is similar to the way I used navigable set when I was working with a tree set. This means I'll have access to all the additional methods on both the navigable map interface and the sorted map interface. Next, I'll include a method on this class called addPurchase, and I'll make that static and void. I'll pass the student name, a course, and the price the student paid for the course. I'll create a local variable called existing student and try to get that from my students map using the name. If that's null, the student's not in the map, so it's a new student. In that case, I'll create a new instance of student using the constructor with name and one course. I'll put this new student in my map with the name as a key. If I did find the student in the student map, I'm just going to add the course to this existing student. This code is going to let me keep track of my students and which courses they're taking. Next, I want to do the same for purchases. I'm going to set up two local variables, day and key. For now, I'll set day equal to the number of purchases I've had, plus 1. I'll explain why in just a minute. The key for my purchase map is a combination of the course ID and the student ID. To get the current year, I can use the local date, and it's now method, which gives me the current date from the system clock in the default time zone. I can chain the getYear method to that call, which will give me back an integer for the current year. Now I want a new instance of the purchase record, and I'll pass that the course ID, the student ID, the price, the current year, and my day variable, which is just a number from 1 to whatever the maximum number of purchases is. Finally, I'll put the purchase in the purchases map using my key. Now I can go up to the main method. I'll set up a couple of courses, the first for my Java Masterclass. I'll use my course record and I'll give this some kind of course ID, like JMC101, and that's my Java Masterclass and the language is going to be Java. I'll assign that to a local variable I'll call JMC. I'll do the same thing for the Python Masterclass, creating a local variable called Python. I want to add some purchases next. I'll start out with 5 students, calling the addPurchase method, passing the student's name, the course, and a price for each. My first student will be Mary Martin, and JMC is the course, and I'll just assign $129.99. I'll repeat that for Andy Martin JMC, $139.99. And let's say Mary's also taking the Python course and her price $149.99. Now Joe Jones JMC and his price, and Bill Brown Python and a price for that. The prices might be different based on special coupons and sales prices. I want to print my purchases and my students now. I'll use the for each method on the map to do that and print the key and value of my purchases. And I'll do something similar this time for my students. Running this code now to see what we get. I've got 5 purchases and 4 unique students. The purchase map's a linked hash map, which means it's ordered by insertion order. This is why I wanted the day of year for this first test case to be equal to the purchase size. This makes it a bit easier to see that the entries are listed in insertion order, which is the order of a linked hash map. However, my students are in alphabetical order. My key was student name, and that's how the students are sorted. You can see the student ID and the courses being taken by each student, and right now only Mary is taking more than one course. Okay, so that's the difference between how a tree map is sorted and how a linked hash map is ordered. What's kind of nice about a map is that most of the time you'll be using simpler types as keys, although that's not always going to be true. But the simpler types, like the strings I'm using for my key in the tree map here, have a natural order and already implement comparable. Next, I want to go to the addPurchase method on the main class and change my expression for setting the day. I could use the local date.now feature and get day of the year for the current year, but I want to mock up my data a little bit. I want to limit the options for this to be the first 4 days of the year. I'll change the expression after the assignment operator. This time I'll make a call on a new random instance and execute next int on that, passing 1 through 5. This will return numbers 1 through 4, which means the possible days of the year for this test are going to be January 1st through January 4th. I'm interested in understanding my sales for each day, so what I'll do here is create a new map in the main method. I'll set this up using a navigable map reference type. This map should be keyed by a local date, and the value is going to be a list of my purchases for that day. I'll assign that to a new instance of a tree map. To populate this map, I'll loop through my purchase map's values, which are all purchases. I'm going to execute the compute method on my new map dated purchases, passing it first to the key, which is going to be the purchase date, and that's really a method on the purchase record. I'll set up my Lambda expression using the purchase date as the key, and the current value a list, which I'll call plist. In the body block of the Lambda expression, I'll set up a local variable, a list of purchases, and call that simply list. I'll assign it the result of a ternary operator, so if plist is null, which it will be if this is the first entry for the date, I'll assign list a new ArrayList instance. If this is already in the map, plist won't be null, so I'll return plist. I'll add the current purchase record to the list variable. Lastly, I'll return list from this Lambda, and that's what gets put into the map. That's the code that sets up my map by dates. So next I'll print the entries out by each key value, effectively each date. If I run that now to see what we have, I'll get different purchases for different days each time I run this. What I want you to see though is that my map is organised in chronological order. Let me add some new students to make this more interesting. I'll add 5 more students, dividing them between the Python class and the Java class with various prices and names. I'll set up Chuck Cheese to take Python, Davy Jones JMC, Eva East Python, Fred Forker JMC, and finally Greg Brady. Since I have a larger set of students, I'm going to change the day local variable in my add purchase method. I'll have the random method pick one of the first 14 days, so I'll change 5 to 15 there. I'll run that, and that gives me 10 students with various purchases for the first 2 weeks of this year. Again, this will change each time I run it. This video is starting to get long, and this feels like a good place to end. In this video, I've shown you examples of using a linked hash map as well as a tree map. For the tree map, I've used a string as a key, but I've also used local date as a key as well. In the next video, I'm going to continue to use the tree map to help make sense of my purchase data using methods on Navigable Map to achieve this. I will see you in that next video.